Well, hello guys, here Mr. G with another video. This time we're going to be solving another question for the grade 10 that also are going to write the exams very soon. But before we carry on, subscribe for the channel so you can get all the notifications and videos I post on regular basis. This question is question 3 from the Gauteng province done in 2022 at the final examination. This question says a car A driving at 135 kilometers per hour approaches a stationary car B, and the car B is stationary. Therefore, the initial of car B in the velocity initial of car B is equal to 0. Okay, the driver of car B noticed that car is approaching him at a very high speed. The driver of car B reacted suddenly by accelerating his car from rest at 1.5 meters per second square. So the acceleration here is equal to a positive 1.5 meters per second square. Right? It's positive because it's accelerating. The velocity is increasing in the positive direction for 11.5 seconds. So the time is equal to 11.5 seconds. And after 11.5 seconds, the car B continues driving. Okay, so that is the final equation. That is the question. Now, question 3.1: convert 135 km per hour to meters per second. How we do this? Quite simple. You multiply by 1,000 and you divide by 3,600. That's all we have to do. And you will get that the answer is 37. Let's fix that. 37.5 meters per second. That was the first question there, and it's quite simple. Question 3.2: determine the velocity of car B while traveling to avoid car A. So here is the data we have, right? And according to that data, we have to select a formula that we can use to calculate what they asking us. Now guys, what you have to do, you have to get this data, go to the formulas which are here of motion. We're working with motion, so we're going to look for the formulas of motion, and out of these formulas here, we're going to look for which one can help us. Now remember, initial velocity is 0. We have that the time is equal to 11.5 seconds. We have that acceleration is equal to 1.5 meters per second square, and we're looking for the final velocity of the car, the final velocity after 11.5 seconds. That is what we're looking for. So out of all these questions, of all these formulas, which one is the one that best can help us with this question? Well, it is the first one, this one here, because it has all the variables we're looking and we have. Okay, so that is the formula we are going to use. So let's come here and say question 3.2. I'm not going to rewrite the data because it is there. Formula that is going to help us: final velocity is equal to initial velocity plus the acceleration multiplied by the time, and then you will substitute. So the final velocity is equal to 0 plus 1.5 multiplied by 11.5 seconds. And then when you solve this one, you will get that the final velocity is 17.25 meters per second. Now, know the following: velocity is a vector quantity. They ask to determine the velocity. It's a vector quantity. And in this question, they don't speak about a direction. So all I'm going to write here in the positive direction. Direction should be given because it is a vector quantity. And guys, this is the final for question 3.2. Question 3.3: how far has car B driven after 11.5 seconds? So now, what is this question asking? It's asking for the displacement, how far it is been, the car after that specific time. So this is question 3.3. Now let's rewrite here data, which is the same one. I just want you to see the same one. Initial velocity is 0. Now final velocity is new. We have it. It's 17.25 meters per second. We have the acceleration, which is equal to 1,5 meters per second square. We have the time, which is 11, well, that's not an 11,5 seconds. Now, with this data, we're looking for the displacement. We want to know how far is the car. Once more, let's go to the formula and see what of these formulas can help us according to the data we have. Well, all of them can help us. That is the good news. Either that one, let me change the color quickly. Either that formula, that one, or this one, because we have all the data. So which one I'm going to use? I'm going to use this one. I think it's a little bit easier, but you can use any of those three formulas. It's important to always come to the formulas which you have your data and you know what you need and what you have. So here we are. So I'm going to write the formula. Displacement is equal to initial velocity plus final velocity divided by 2. Right, multiplied by time. This one is the formula, and then we substitute. The initial velocity is 0, the final velocity is 17,25. This is divided by 2, and all that is multiplied by 11,5, and that will give you the answer, which is 99,19 meters. So now they don't ask for displacement, they ask how far is the car. So it's not actually displacement, therefore we don't need to give a direction here. All right, but we're supposed to give the answer in meters, and that is the final answer for that question. Okay, guys, now in question 3.4 we having a small tiny problem which I found out after trying many times and things were not clear here. So now the question says the driver of car suddenly hits the brake and manages to stop after 40 meters. Now to stop means that the final velocity is going to be equal to 0. The initial velocity is going to be the velocity with which the car was moving before. So the initial velocity for car A was equal to 37,5. Let's write it here, 5, because I want to discuss something with you. This car is going to stop after 40 meters. Now, they say that it takes 4 seconds to stop. However, when I done the calculations, there was something not right, because every time I did calculation with different formulas, I got different answers. So let's first of all calculate how long it will take for the car to stop 40 meters. Okay, so if you do that, we can use the following formula. Displacement is equal to initial velocity plus final velocity divided by 2 multiplied by time. Let's calculate the time. So if the displacement is 40, like they say, and we substitute, the initial is 37,5, the final is 0. I'm not going to write it, guys. I hope you are following me right now here, looking for the time. So this one is going to be like 40 multiplied by 2 divided by 37,5, and that will give us the time. So if we do this, actually this one gives me that the actual time for the car to stop this distance from 37 to 5 was 2,1,3 seconds, which doesn't correlate with the 4 seconds. Now, in other ways, let's do something else. Let's see how far would stop if it took 4 seconds. Okay, so if it was 4 seconds, how long it will take? How far will stop from then the moment it press or put the brakes? This is calculation to see that there is a little bit something not looking nice here, which means there is a mistake with either number. So let's calculate quickly the displacement. Okay, if the time was 4 seconds, and we're going to use exactly the same formula. Let's calculate the displacement if the time was 4 seconds. So same formula. I'm not going to rewrite the formula, just going to substitute. The numbers here will be 37,5 plus 0 divided by 2 multiplied by 4, and then the displacement is going to be 75 meters. So what I want you to know here, the displacement is 75 meters. Is that there is a tiny mistake with the numbers. These numbers are not properly. So what we're going to do is the following. We have to calculate the acceleration, which is the question. This is not really a big issue. We are going to do it using the displacement and going to ignore this 4 seconds there. So we're going to ignore all this part. Is not going to be in the question. Okay, I hope you agree with me. Let's do it with the 40. So the question say calculate the acceleration with what you have. So let's do it in this tiny corner here, and let's see what we actually have. This is question 3.4. So let's write the data, and what do we have? We have that the initial velocity 37.5 meters per second. We have that the final velocity is equal to 0. We have that the displacement is equal to 40 meters. We're looking for acceleration. So what is the best formula to use here? And then according to the data, this is the only one we have to calculate there. So we are going to take that formula, do the substitution, and calculate the acceleration. Okay, so we write in the formula now. Velocity square, final velocity is equal to initial velocity square plus 2 multiplied by the acceleration multiplied by the displacement. And all you have to do is to substitute the final velocity 0, the initial velocity 37.5, and all that is a square, plus 2 multiplied by the acceleration multiplied by the displacement, which is going to be 40, and then this is just rearrange and calculate. When you do this calculation, this is what I get: negative 17.58 meters per second square. That is the answer. And now something important here. They ask you to calculate acceleration. Acceleration is a vector quantity, therefore it have direction, and this minus here, guys, this minus there means direction. So that means that this is in the opposite direction to motion. So this is the question. I hope you understand. I am sorry about that little mistake that is in the question paper. But well, this is the question. I hope it helped. I'll see you next time. Subscribe for the channel. Thumb up. Mr. G here.